Okay, this is the formula for compound interest, and in the previous video I talked about what is compound interest, and so now I want to talk about how do we derive this formula. It looks a little complicated, but if you understand what compound interest is, then you'll find that actually doing the math to derive this it's not too bad. Okay, so let's just briefly go through what our variables are here, and then we'll get into how to derive this. So A is the amount that you have at the end of a certain amount of time. Okay. P is your initial amount or your principal. R is your annual interest rate. It's very important that the unit of measure for however you've defined R needs to match the unit of measure for N and T. So N is the number of times your interest rate is applied per year. So you see the unit of measure matches annually versus number of year. And then T is the number of years. Okay. N times T, let's talk about that briefly, because that's actually a really important concept to deriving that formula. So N times T would be the total number of times interest is applied in T years. Okay, and to think that through, you can just think through like maybe a simple example. Suppose you compound your interest 12 times a year, so maybe monthly. Then T might be 2 years. You're waiting for 2 years. Then the total number of times you've compounded is 24, right? So the number of times you apply your interest, and then times the number of years. When you do that multiplication, you'll get the total number of times that the interest is applied after a certain number of years. Okay, so let's just kind of draw through what's going on here. So suppose NT equals 0. So you haven't applied any interest at all. All right, I'm going to introduce a new notation of A subscript 0. And so the subscript is the number of times that you've applied your interest. Okay, and that's why this N times T is so important. So A subscript 0 would be the amount that I have at that time, which would just be whatever your principal is. Okay, let's go ahead and change colors. So now when I've applied my interest once, N times T is 1. How much money will I have? Well, I'll still have my principal, but now I'll also have my principal times my interest, which would be my principal times R over N, right? So whatever my interest rate was divided by however many times I'm getting it per year, right? Multiply that by the principal, and then so that's basically my dividend or my interest, and then add that to whatever my principal was. All right, this is the amount of money that I'll have at the end after I've compounded once. Right? And so I can simplify this equation by taking out a P, and I'll be left with 1 plus R over N. Okay, so I've factored out a P, and this is what I get for A1. So the amount that I'll have after applying my interest only once. So now when I apply let me go ahead and change that color. Let me try to color coordinate things here a little bit. Okay, now I've applied my interest twice. How much money will I have? Well, I'll start with the amount that I had the previous time I applied my interest. So I'll start with A1, right? That's what compounding does. Instead of starting with the principal, I'm starting with the amount that I had previously. And then I'm going to add my interest, which is the amount that I had previously times R over N. Okay? Okay. So now I know what A1 is, right? I know what A1 is. I can plug it in. So I'll have, let me go ahead and plug in A1. I'll have P1 plus R over N. Okay. Then I'm going to plug in A1 again. So I'll get P1 plus R over N. All right. So you see all I've done is I've plugged in for A1. Now I notice that this is the same term, so I can pull it out. So I'll have P, okay, times 1 plus R over N. And then when I pull it out, I'll be left with a 1 here. And then I'll be left with R over N here. Okay. Maybe it would have made more sense had I pulled out the A1 first. Okay, and then plugged in for A1. Either way, you see I get to this point. Okay, and then I notice that these two are the same terms. This is repeated twice and it's multiplied. So that's the same thing as it being squared. All right, let's do this one more time. Suppose now n times t equals 3. So I'll have the amount that I had previously, A2, and then the amount that I had previously times R over N. Okay, so that's my interest. Okay, so first thing, let me go ahead and factor. Let me factor first. It's a little bit easier to do it that way. Okay, so you can see I just pulled out the A2. Now I want to notice, okay, so here's A2. This is the formula for A2 right here. So let me plug this in. Okay, let me scroll down a little bit. So I get, and let me keep my color coordination. So I have P1 plus R over N squared. So I plugged in for A2 times 1 plus R over N. All right, and I notice these are like terms. So I can say it's to the third power. Okay, so now I'm starting to see the pattern, right? I'm starting to see that whatever n times t is, that's the power that I'm bringing this 1 plus r over n to. Okay, so in general, what is my formula at the end of the day? My formula is A equals P 1 plus r over n to the n t power. So the amount that I have after n times t compoundings, or after a certain amount of time t, would be this principal times 1 plus r over n to the n times t power. All right.